The kinetic molecular theory describes the behavior of gas molecules and the physical properties of gases. The kinetic molecular theory views gases as being made up of large numbers of fast-moving particles that are far apart from each other. Most of the volume occupied by a gas is empty space. Gas particles are in continuous rapid random motion, and the forces of attraction or repulsion between them are essentially non-existent. Kinetic molecular theory relates the kinetic energy of gas particles to the temperature of the gas. An ideal gas behaves as described by the ideal gas equation PV equals nRT. There are several assumptions about the nature of a gas that are required for it to behave ideally. A key assumption is that the gas molecules occupy no volume. In a real gas, the molecules have a small but positive volume. Another important assumption is that kinetic energy is dependent on temperature. This means that the molecules are moving at a speed dependent on temperature. Real gases have molecules moving at a variety of speeds. Ideal gases collide like billiard balls and bounce off each other while maintaining their speed. They do not stick to each other or their container walls. Real gases occasionally stick to each other or the container walls. Ideal gas particles are always moving, but collisions that lead to sticking can cause real gas particles to violate this rule. Ideal gases do not attract or repel each other. Sometimes real gases do attract or repel each other.
During an inelastic collision, the objects deform and they move separately after the collision. The total kinetic energy decreases. During a perfectly inelastic collision, the two objects stick together and their final velocity is the same. The total kinetic energy decreases. During an elastic collision, the objects bounce apart and move separately. There is no change in the total kinetic energy.